Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss the MCQ about ketene. This molecule is known as ketene. Okay, so its reaction with MCPBA and final product. So you have to find out what is the structure of the final product. By the way, such kind of question could be useful for exams like BSMS, B.Sc, M.Sc, or you may consider the bachelor and master degree equivalent exams in chemistry or competitive exam like CSIR-NET, GATE, IIT-JAM, etc. exams. So a lot of interesting chemistry to be learned in this video. Please watch until the end. First of all, as usual, I first request you please pause the video and try by yourself. It will help you for self-evaluation. Secondly, don't worry. So after that, I shall explain the answer, and at the end of this discussion, I shall provide a short tricks that how to solve such kind of question within 30 seconds to 1 minute. Okay. So a lot of chemistry to be learned. So before going to details, I want to mention one thing. Just keep it in mind that questions are not repeated or not. You don't expect that you will have common question, but the concept or understanding may be common because it is common for every case. Whatever question is constructed based on understanding. So for that reason, it is essential that you must understand the concept, and for that purpose, it is essential to learn the properties of the reagent. Okay. So in this case, we have two reagents. One is ketene and one is MCPBA. Let's learn briefly about ketene, what this molecule actually is. See, ketene is a means adjacent double bond. Okay, so one important thing that if you consider that this double bond, this is double bond 1 and this is double bond 2, 1 and 2 double bond is not in conjugation. How? Just look at the orbital picture. See, if this C double bond, this carbonyl is a overlap between the two pi orbital, p orbital. So in this way it's overlap. Fine. Now, so what about the other carbon means number 1 number, this CC double bond, how it forms? It forms by parallel overlap but in a different plane. What do I mean? This. Okay, so you may consider like this. And what is the angle between these two pi bond? So this is a pi 1, sorry, this is a pi 2 and this is a pi 1. So the angle is 90 degree. Okay, so they are perpendicular planar to each other. So that's why they are not in conjugation. Okay. So do not make this mistake that they are in conjugation. They are not in conjugation. Fine. Point number 1. Second. So electron richness. See, pi bond 2 is less electron rich than pi 1. Why? See, this pi bond 2 in this case there is a electronegative atom oxygen. So electron density on this pi bond is less. Pi bond electron density means actually after this overlap it constructs a pi orbital. This is the pi and electron density here, and actually this reagent is electrophilic epoxidation. So I will discuss where the pi bond participates in the reaction. So fine. So here electron density less, so reaction is expected. So just remember the term. This is electrophilic epoxidation. Okay, there is another term nucleophilic epoxidation which I will discuss very briefly at the end. Okay, so this now question, which one is electrophile? Then simple question. So this MCPBA, this meta-chloro benzoic acid is electron deficient, and which part? See, in this molecule this epoxy part is electron deficient, and where electron goes to the sigma star of this oxygen bond. Actually, why they are electron deficient? See, two electronegative atom attached to each other, and we know the lone pair of these two repels each other, which is known as alpha effect. Okay, so that's why they are not stable. So point number 1. So reaction will happen on this. Second, among these two double bond, this is more electron rich. So this will act as nucleophile. Okay, so we have understood the electrophile, we have understood the nucleophile as well as the orbital conjugation in ketene. Parallel to ketene, you can remember one additional molecule which is very important from stereochemistry point of view. This is, see, one carbon, see that oxygen, this part is replaced by the carbon. Okay, so this is known as alene. We will discuss some other day about this moiety. Okay, so now let's go to the discussion of the mechanism, how the reaction happen. So as I told, the MCPBA, it's an electrophilic reagent, and actually the peroxo bond is important for this reaction. This is the air part. So what happens? This double bond, the double bond of this carbon-carbon double bond, pi of this, which I discussed previously, attacks the sigma star of this O. Consequently, what happens? It leaves and it stabilizes through the conjugation. Secondly, the lone pair, because after attack this carbon will have a positive charge. Fine. So consequently, in order to neutralize it, this attacks. Okay. So ultimately, what it results? A 3-member ring. Actually, this is epoxide, but since it attacks to carbon, it is called as lactone or 3-member lactone. Actually, lactones are nothing but cyclic ester. Okay, so these lactones are produced. Now question, this is unstable. Why? So first of all, point number 1, this is strain. It has a strain. Why? Because see, it's a 3-member ring. It's a 3-member ring and there is one CO double bond. So first of all, strain because 3-member ring around 60° angle, and second there is a sp2 carbon. Okay, so this is strain. This is point number 1. Point number 2, what happens about this MCPBA? So this results in this means meta-chloro benzoic acid. Okay, so this meta-chloro benzoic acid can produce H plus, means acid. So what can happen? These H plus helps to open up the ring. Means actually logically you can consider this carbonyl oxygen, logically this carbonyl oxygen is more electron rich, protonation should occur here, and what happens? This protonation occurs. Okay, so this, now if this carbonyl oxygen is protonated, then electron deficiency increases. Consequently, the probability to break this 3-member ring, just look at this, increases. So this is, you may consider it's protonated. Now, so probability of breakage is increases. So consequently, what happened? It breaks and the negative charge comes on this oxygen. Okay, and another thing, this negative charge comes oxygen means what does it result? It results in, you may consider that, you can think like that, this charge comes here and it opens. So in this way, one is OH and one is O, and positive charge is here. So since it's a carboxylic acid, so it can remain, not only this, it can remove the proton and remain in this. So this is minus removal of proton. Okay, so point number 1, breakage. What is the reason for the instability of this strain of 3-member ring? And point number 2 is presence of acid. Actually, this is so unstable that only spectroscopically you can detect. For example, FTIR you can detect, but very soon it rearranges to something else. Okay, we'll come what is something else. So now we understand that how this carbocation is formed. Now look at here that this carbocation is a tertiary, just this. So it is a tertiary 3-degree carbocation, but it is only stabilized by plus I effect. Why? Because here only 2 methyl groups are there, which can show, means actually there are tertiary butyl groups are there. So this is T-butyl, so they can only show the plus I effect. Okay, so only plus I effect, but no hyperconjugation based stability. So consequently what happens? that we know that carbocation can undergo rearrangement. So rearrangement is possible. So what happens in this case? This is nothing but rearrangement. So rearrangement happens what? This methyl group migrates from here to here. So what is the consequence of this? See, this is also a tertiary carbocation. So this is also a tertiary carbocation is produced, but it has plus I effect as well as 6 hyperconjugation. So what do I mean? This plus I effect plus 6 hyperconjugation. So what is the advantage? So this is fine. Stability point of view, both are fine. But now see, previously actually these charge separated species means this is cation and anion, they remain in equilibrium, they can further combine, but they will break instantly since it is unstable. Fine. But in this case, what advantage is achieved? See, this oxygen can attack here and it can result, that is a 4-member lactone. So what is the advantage compared to this 3-member? So in case of 3-member, there was a strain. 3-member, since it's 3-member, so angle is around 60 degree you may consider, but in this case it's a 4-member, angle around 90 degree. So we can say that ring strain is released. So that is the advantage. Okay, so this, now we understood how this reaction occurs and what is the product. Now let's go to the problem. So what is the product of this problem? The product is this one. Okay, this. So now a question, if such question comes in your exam, how can you solve this question within 30 seconds? First of all, you need to understand MCPBA, it's an electrophile, electron deficient, and electrophilic epoxidation occurs using this reaction. By the way, I have already uploaded lectures about electrophilic epoxidation using MCPBA. Fine. Seconds, what happens? See, in this case, which double bond will undergo this? Since it is a electrophile, so it will prefer to have an electron rich double bond. So this is now it will undergo epoxidation. With a blank eye, just you write that in your book. This is that epoxidation. See, double bond O. Okay. Now, when you write this, just see it's a 3-member lactone, always unstable, point number 1. Second, it is in acid medium, means this MCPBA will produce acid after reaction. And another important information, by the way, this MCPBA, if you consider acidity of this versus corresponding meta-chloro acid, this meta-chloro number 2 is more acidic. Why? Because the corresponding carbon ion O- is directly in resonance with this carbonyl, whereas in this case this minus is not direct in conjugation. Okay, that's why this is actually a good, so this is actually a good nucleophile but poor base, but in this case this is poor nucleophile, but sorry, actually this is not a, this is a good nucleophile. So proton removal is not that much easy, but it is a strong, relatively stronger acid. Fine. Now, so it will break. You have to think, just forget this explanation, just it will break and ultimately result in a carbocation formation. And if it results in a carbocation, that can undergo rearrangement here and ultimately carbocation will come here and the O- can combine. Okay, this is the overall justification for this, but this is if you know the chemistry completely. But if you don't know the chemistry completely, based on common sense, what you can think? So based on common sense, this MCPBA epoxidation will occur, fine, first point, but it will not undergo further oxidation. Okay, so epoxidation, okay, so this is not possible. 1.1, it's gone. Second point, epoxidation about this, fine, but will it be stable? No, 3-member lactone, unstable. Point number 2 gone. Now second thing, see, in this case, if that is MCPBA, means some water may be there in the reaction medium from where it could be both positive, means for example, if you react this thing with water, what it is expected to result? This, and we know the carboxylic acid will attach to the proton and here carbocation, and water means the water means actually HOH. So at this position there will be OH attached, because OH will attach. So this is also not possible. Okay, so ultimate sorry, not this is also not possible point. So ultimately this is left. So based on common sense also you can solve within 30 seconds. So first of all, what is needed for that? Knowledge about the reactivity of reagent, and second, practice. Okay, so wherever you find MCQ, please do practice for self-evaluation. Okay, so this is the overall discussion. Now what we have learned from this discussion: first of all, MCPBA, meta-chloro-benzoic acid, oxidizes carbon-carbon double bond to form epoxide. Okay, fine. Second, and actually this is the electrophilic epoxidation. Next slide I shall explain about very brief nucleophilic epoxidation. Now 3-member lactone is less stable than 4-member lactone because of strain. Okay, now, and another thing, rearrangement of carbocation, rearrangement from one tertiary cation can undergo further another tertiary carbocation, because generally we know the stability of tertiary more than primary more than, so rearrangement follows this stability order. But tertiary to tertiary possible if there is some other advantage. Okay, so this we have learned. Now let's learn very briefly about the nucleophilic epoxidation reaction. So first of all, why this is needed, nucleophilic epoxidation? Because see, look at this compound. So this is this is a alkene. Actually this is alpha-beta-unsaturated carbonyl. Okay, so what happened? So carbonyl. So because of the resonance, this resonance means, let me draw the canonical form. Because of the resonance, the electron density on this carbonyl group is less. See, this carbon bears some amount of positive charge, so it is not a good electrophile. However, this or this actually are nucleophile. We know soft and nucleophile, and I have uploaded lectures about Michael addition and property of alpha-beta unsaturated carbonyl compound, where you can clearly observe that this is a actually electrophilic center, electron division. So nucleophile can attack here. Okay, actually nucleophile can attack here, not electrophile. Very difficult. So MCPBA cannot attack here, point number 1. And second, there is a ketone, so there is a chance of oxidation into ester using MCPBA. Okay, so in this case methyl you may consider, whatever in that. So I have discussed that thing also in some another discussed video. So what is the option? In this case, the proper choice of reagent is hydrogen peroxide sodium hydroxide. Why? Because it resulted in the production of hydroperoxide anion, and this is a good nucleophile. Okay, so this is a good nucleophile, so it attacks here, and in this way reaction proceed. I have made a dedicated lecture, please visit that for details understanding. So this is the overall understanding of this process. Now, so this is the end of this discussion. I hope this video may be helpful for you. Write me in the comment box, and if you really think this video is good and deserving, please share it to your friends such that they can also enjoy the benefits. So till now, thanks for watching. Stay happy, stay blessed. See you in my next video. Bye bye.